Welcome everybody. This is part of Staffordshire University webinar series named Staff's Innovate webinar series. Today I'm going to talk about intelligent autonomous robots. So let's start. First, I would like to give a brief introduction of myself so that you can recognize who am I and why I'm here. I'm a lecturer at Staffordshire University. I got my bachelor degree in electrical engineering. Then I got my master's science degree in computer engineering and finished my PhD in autonomous intelligent systems. My research interest includes robotics, AI, machine learning, and computer vision. I have taught robotics and machine learning for more than 15 years in different universities and different countries, including Japan, Iran, and UK. I have many publications in these fields, and I also have many industrial project experience in different industries, including petrochemical industry, car industry, oil, and etc. If you have any question during the presentation, you can use the chat facility to send and type your questions. For other questions, either you can write to my email, saeed.shiri@staffs.ac.uk, or for general inquiries, you can write to employers@staffs.ac.uk. You can find more information about this webinar series in our university website. Once again, I thank for all of you for attending this presentation. I hope that you get enough from the time that you put for this presentation. Because I had no idea about the background of the attendant, I tried to limit my presentation on my experience and on my project done about robotics. So I first will give an introduction to industrial robots and also intelligent industrial robots. Then I will follow to the case studies, including social robots, inspection robots, humanoids, telerobotics, and some other case studies, depends on the time. And also I will try to give some explanation about the techniques related to the industrial intelligent robots. I'm sure that all of you that are here in this webinar are aware of the robotics and what is called a robot. We call a robot a machine which has mechanical part to move itself or something in the environment. This mechanical system has to be programmable. It means that you need to be able to change the functionality of this mechanical system and control the abilities of this robot. Any robotic system needs some kind of actuators to act on the environment and some kind of sensors to sense what is happening in the environment and the consequence of acting on the environment, and also the control system. The first robotic systems, in fact, were made to imitate human arm, so we call them robotic arm or manipulated. They are most similar to human's arm, and they have usually 6 degrees of freedom to manipulate objects in the environment. These kind of robots are the dominant robots available in the industry. If you look at any developed country, any country with developed, in fact, factories and industries, you see many of such robots working in this industry. Almost a few major companies make such industrial robots, and they can almost handle every requirement that the companies and factories need from such robotic manipulators. But the interesting thing is that this industrial robotics era is a little bit going to finish. It means that the application of industrial robots are limited. They can be used in environments that are fully engineered. You know that the environment in the companies or factories are fully engineered. Every piece of the environment are well thought and well designed for safe operation of the robots. The robots in factories usually do repetitive work, and they work in a controlled environment, and they usually are used in a production line for producing materials that long for a long period, that last for a long period of time. Typical application include welding, painting, assembly, pick and place, packaging, labeling, and palletizing. The robots can do such applications with high endurance, speed, and precision. But now we are facing a really interesting paradigm shift from industrial robot to intelligent robot. This paradigm shift has been available due to the advancement in robotic and AI research. In fact, we have seen many important advances in AI technologies and algorithms, especially in computer vision, because computer vision has the same functionality for the robot as human being. For human being, more than 90% of our information and perception of the environment depends on our vision. So due to the advancement in computer vision and AI algorithms, now we can bring the same level of perception and understanding and knowledge about the environment for robots. So it means that robots can, we can expect robots to do almost everything that a human being can do, because they are going to have vision, something that was not possible, for example, 10 to 15 years ago. Also, there have been good advancement in communication. Now we can hope that we can communicate with robots using natural language. If this barrier is solved, then we can see that robots will work not only in factories, but almost in every place, I mean, that you imagine. The limit of the new intelligent robots application is, in fact, human imagination. What any kind of imagination can end up making an innovative and new robot. In fact, in the beginning of 21st century, the industrial robot was born again as an industrial intelligent robot. As I told in previous slide, industrial intelligent robots use a combination of ordinary robots plus AI. And from AI, usually we mean that they have vision and intelligent force sensors. And I can talk for months about intelligent robots, but as I told, I would like to limit my presentation to only the projects that we have done to realize intelligent robots for industry and also for other applications. I start my first case study with a very important and essential ability of an industrial robot. In the factories, ordinary industrial robot can pick up only the objects that they have been programmed and they have been taught by the operator in advance. But if you are going to bring an industrial robot to everyday life and ask him to grasp any arbitrary object, then the robot should have the ability of selecting the proper position and location for grasping any arbitrary object, any object that was previously unknown to the robot. We have done several interesting projects, mostly master's degree projects that teach industrial robots the best place that for grasping that object. In the picture, you see different objects and the offering of the algorithm for grasping. For sure, it is only one part of the grasping, because after the perception or understanding where to grasp, the robot needs to plan to reach that position and also use control algorithm to apply enough force to be able to locate that object. We have applied several techniques, mostly using deep neural networks and CNN architecture for detecting grasp location based on the RGBD image of the object. As I told previously, unfortunately, I don't have any clue of the background of the respected audience, so I just limit technical details to your questions. If you have any question about the implementation methods of any technique that I'm mentioning in this presentation, you can simply write me email, and I would be more than happy to give details of the implementation. So this was one example that how we can change an ordinary industrial robot to an intelligent industrial robot using machine learning and deep learning techniques. We also had another interesting project. We did it for a car assembly plant. In car assembly plant, they use robotic arm to for glazing glasses on the car window. For an industrial robot to be able to do this glazing job, the robot needs to detect the precise location of the window, and it's to be done with sub-millimeter precision, because even a few millimeter misplacement of the window will make the window pins to break and to make damage to the company. We used almost 8 different cameras and a sophisticated computer vision algorithm to detect the precise location of the window on the robot, and we could locate the correctly and guide the robot to install the glass on window. It was a very successful project, and the assembly line is still using that device. Another industrial project for bringing intelligence to robot is related to warehouse robotics. In fact, warehouse robotics is a very, very hot topic today, because with COVID-19, and which made people to go for online shopping. The online shopping websites has to be very fast to be able to deliver any application that they receive, any inquiries that they receive. So without proper robotic and automation facilities, they won't be able to reply to any inquiries, to all inquiries that they get from the customers. There are many commercially available warehouse robotics. What we did as a project for one food factory was that, in fact, we made an autonomous robot teachable, in fact, by operator. In this project, the operator uses his hand gesture to give commands to the robot, such as follow me, stop, turn, or such simple commands. This robot, in fact, helps the operator to do his functions with more speed. The operator moves in the corridors of the warehouse, and robot follows the human. And when human stops, robot stops too, and human loads the robot and gives hand gesture command or voice command to the robot, and robot takes the goods back to the predefined station or a station that were commanded by voice by the operator. So it is also a project that is being used in that warehouse. Another industrial application of the intelligent robots is poultry robotics, which is going to change the face of this sector. What we are going to do for this sector is introducing very, very low-cost intelligent robotic system, because this product is not expensive one, and farmers cannot afford for high cost intelligent robots. It's some kind of contradictory request. In one side, we want to have intelligent robots. It means that you need the robot to have, for example, camera or localization system and a computer to analyze the pictures captured from the camera. On the other side, you need these systems to be inexpensive and low cost. So we are going to, in fact, use some kind of embedded vision system to make this robots cheap, affordable, and easy maintenance for this industry. Another project that is ongoing in our university and related to intelligent robot is TELEPRESENCE. A TELEPRESENCE robot is a remote controlled, in fact, robot. It has wheels, and communication means usually camera and microphone, that the operator can see the environment using the robot and the camera, and can interact with the people in the environment with microphone and speaker. But there are many limitations in the teleoperation of the robot through distance by untrained people, and it's really uncomfortable for many untrained people to do telepresence. So we are going to introduce some kind of intelligent to telepresence robot. In fact, that we want to lower the level of human operator functionality. I want to limit the functions that the operator wants to do to very high level ones, and let the robot do the others autonomously. For instance, if a doctor wants the telepresent robot to go to the patient, it's simply ask this request by verbal or text or any other means, and the robot itself finds the patient and go to the proper distance from the patient. This is our ultimate goal from this project. Another very interesting project that we have done with intelligent robots is teleoperation using piezo actuators for cell manipulation. In this is a telerobotic operation, but with the difference that you have micro macro teleoperation system. It means that the operator wants to do a very tiny movement, for example, a sperm injection, which is done in traditional application with lots of error and cost, in fact, for the patients. Usually they do it using a microscope. They see the sperm using microscope and manipulate it by hand, which is very, very difficult and needs a lot of training. What we did was to use piezoelectric actuators to do this movement and do this operation, and but the operator uses an ordinary joystick for movement of the sperm. With this kind of micro macro operation, we could reach a high level of success. We needed a precise modeling of the movement of both parts, and also an accurate control model to be able to do it without, in fact, damaging the sperm. So, as another kind of intelligent robot, I can name humanoids. We have quite extensive experience in making and programming humanoids. With a humanoid, you can say that any action that a humanoid wants to do needs lots of AI and machine learning algorithms. Even a simple walking or climbing stairs or any other action needs AI techniques to be involved. The picture shows the robot that we have developed for an educational purpose. This robot has 21 degree of freedom and can be used for education of kids, either itself, the robot, as a educational case study, or either being used as assistant to teachers or helping the students to understand the subjects. We also have experience in using Pepper robot. The Pepper is a commercially available humanoid robot. The first humanoid robot that I showed you was made in our department, but this robot is commercially available. That there was a lot of advertisement and propaganda for using this robot. Unfortunately, this robot was a complete failure due to a simple fact that people expected this robot to have high level of communication ability, which is not available in these days. It means that for robots such as Pepper to be able to work successfully in society, they need to be able to communicate verbally with human being. These dialogue generations have not been developed yet in that level that they are enough for robotic applications. So we had the same problem with this Pepper robot. So we developed a semi-intelligent user interface that helped our robot to be better acceptable in different situations, and in fact it led our robot to get out of a difficult situation when it couldn't understand the conversation with the people. We also developed different kinds of chatbots. In fact, chatbots are used in many industries, and they can be used for intelligent robots also. In fact, any development in chatbot and dialogue generation system can help us to develop intelligent robots with more speed. And the day that we solve this communication problem with robots, we will see many amazing applications of robots in the market. In our research, and we have developed a deep reinforcement learning dialogue generation system for domain-specific conversation. With domain-specific conversation, it means that our system can be used only for limited conversation with robot, with scenarios for special places such as shopping mall, banks, hospitals, and etc. We have developed many different sections of this dialogue generation, and it is a kind of still ongoing research that we are doing with few PhD and master students involving in this research. Another aspect of robotic intelligent robots is inclusion of the robotic automation as Industry 4 revolution. It is for the first time that robotics are being considered as a pillar of industrial revolution, and it means that robots need to coexist with human in many different aspects and different shapes, and different kind of coexistence or cooperation. One important factor for such robots is safety. You consider that people are going to work with a metally made robot in home environment, and a heavy 90-kilogram robot hits a 10-kilogram kid, and it's not a fortunate moment for the parents. So what we have thought for a solution for coexisting of robots and humans in the same environment is called soft humanoid. We have not been able to develop a soft one yet, because it's really difficult one to make a robot from soft material that is able to walk and cope with human or coexist with human in the same place. But we are working on it. We have developed several actuators and even a moving arm for it. We are working on the modeling, control, and also fabrication side of this soft humanoid. One other aspect of the intelligent robots are their use in smart cities. For sure, if you want cities to be much smarter than they are now, you have to see much more robots working and giving service to different sectors in the city. We have done some robotics research to provide robotic solutions for smart cities. For instance, we have developed different kinds of omnidirectional robots. I mean that robots that have 3 or 4 wheels and can move in omnidirection in different spaces. We also have developed rescue robots, part of the workers of the next generation cities. We have developed flying robots for parcel delivery in the cities. We also have developed sewer inspection robot, and we also have developed home robots that we believe they are part of our future cities. In our research for developing home robot, we have developed a system that we call it HRPS. It's a kind of GPS for indoor localization. Unfortunately, current GPS systems are not suitable for indoor environments, so we had to develop our innovative method for, in fact, imitating GPS functionality in indoor environment for robot localization. Our home robot, in fact, has human tracking ability, human detection, action detection, recognition, and so on. And we also have done several projects on cognitive map generation for mutual understanding of the environment. Usually robots use different kind of sensor for mapping an environment, but the map that robot generates is useful for robotic applications, not for the communication with the human. So we have developed a kind of cognitive map that robots can use it both for its localization and also for communication with the human being. As I mentioned, we also have made a intelligent inspection system. The robot is named Contaro. It can inspect pipes with almost 200-meter diameter, mostly used for sewer pipes inspection. It has both intelligent software for detecting anomalies inside the pipe and also intelligent mechanic system to move inside the bends or junctions of a pipe without external interaction or without the need to any sensing ability. We also have done several research for addressing problems that intelligent robots face inside the cities, such as large-scale SLAM. SLAM is a famous problem for intelligent robots. It means that robots makes map of an unknown environment and then localize itself in the same map. There are many different algorithms for making SLAM, but making SLAM for cities, especially using visual camera, which is called visual SLAM, is a challenging one because the image that we receive from camera are very high dimensional data. And for being able to use them properly, we have adapted, in fact, different kind of dimensionality reduction techniques, mostly based on manifold layering, which help us to minimize, in fact, the size of the image and change one picture to almost very limited dimensions, and then use advanced graphical methods to inference about the position that robot is in the environment. There are also several students working on visual SLAM project too. So I guess my time is over now. Thank you again for joining this conversation. I hope that it was useful for you. If you have any questions, please send it through chat facility. I'm here to reply it. Any other questions can be sent to my email. Thank you so much. So, uh, I don't see any question yet, but I hope that you have some. Uh, if among the audience are any student willing to pursue master degree or PhD degree in Staffordshire University related to autonomous robotic study, please feel free to contact me. I would be happy to help you in this matter. We have very interesting projects, ongoing projects, and I'm sure that the students will enjoy their robotic study in our university. This question from Charlotte about news website that gives readings about the topics. I remember one popular one. I'm not sure about the name. I can find it by searching it internet. But I think it was called Popular Robotics or Popular Mechanics, something like that. That you can find robotic information. If Charlotte, you send me an email, I will send you the link. Sam asks about poultry robots. Yes, Sam, I can give you more information on poultry robot. Please send me an email with the same topic. I will give you what stages or research. Okay, that's all questions for now. Once again, I thank you for joining us today. Have a good day. Take care of yourself and enjoy your study and life. Thank you, everybody.